Hello everybody and welcome to the very first YouTube video dealing with introductory chemistry. Now whenever someone asks me what am I studying in school, I always tell them chemistry. And usually I get the very usual answers like ooh, ooh, all in one. Mainly because chemistry is generally a very hard subject to study in, regardless of wherever you take your courses at high school, college, or some other type of school. Now, chemistry is everywhere, from your water to your cells to every tidbit of life itself. Now, generally, we look at chemistry and we think of shows like Breaking Bad that deals with some aspects of chemistry, mainly drugs. And to the upper right hand corner, you'll see the molecular structure for meth, because, it's chemistry. Many people usually either take chemistry because they need to take it or because they want to learn how to make drugs. There's no in between. And usually chemistry does not deal with pretty colors and pretty beakers making explosions. It usually deals with other stuff like making medicine, learning how to, well, which ingredients will make the best food products. And yes, there is food chemistry involved. And also, we can make other stuff like fireworks or a new variation of a soda, maybe. It just depends on who is doing the chemistry and what type of chemistry is being utilized. Now, for this type of playlist is introductory chemistry. It deals with chemistry that's mostly taught to people who are going to nursing, the dental program, or any other sort of stuff health related, or they just need a GE class. So this chemistry is usually not taken by those who are biology majors, chemistry majors, physics, or engineering majors. However, because some schools often do not include this in their introductory chemistry classes, we will also cover basic organic and biochemistry as well. Because a lot of you are probably watching this are probably into nursing and would like to know about the organic and biochemistry aspects that you will most likely see in your day to day life and career. So let's begin. Chemistry is the study of matter. It's the study of the interaction of matter, why matter does things, and matter is you, I, it's everywhere. It's what makes up the universe. Everything is made of chemistry, as I already said. Everything we do is chemistry. From just listening to my voice, whether it be annoying or like, what is he even saying? You're doing chemistry in your brains because there's all these little tiny chemicals firing all over the place. Now, the reason why we chemists tend to study chemistry is because one, we have no social life and we like pain, but also, even though you probably at the end of this playlist will probably hate chemistry more than you already do now, you might find it a tad bit interesting. I remember being in high school, I hated chemistry with a passion. Like, I just wanted to rip out my teacher's throat whenever there was a test or a lab. But after going to college and taking chemistry courses, I realized it's not so bad. Plus, we get to make little nerdy chem jokes that hardly anybody understands, which makes life really, really sad for us. But hopefully, after taking this course, you'll be able to understand some of the little chemistry puns. Now, the requirements for chemistry is one, be curious, be open minded, and love or learn to love fire explosions and know your math. It will come in handy when later on we'll be covering multiple calculations and finding out the grams of sodium. We all know that chemistry is tough and will kick your ass, believe me. I'm in organic chemistry second semester right now, and already my ass is getting kicked. And like I said, there are some positive attributes to chemistry, and my goal is to help make chemistry concepts that you learn in class simple and hopefully try to convert you to my church of chemistry, where, and you'll later understand what I mean, Avogadro becomes your god. Now, the one thing that chemists utilize the most is the scientific method. Now, what is the scientific method? The scientific method is basically a process of how we go from observing what's happening in nature to doing stuff in the lab to working up all those crazy numbers that you see sometimes in TV shows to developing general ideas of why these things occur and what's making them happen. Now, when we make observation, let's just say, why doesn't my cat talk? Well, that's an observation. We make it and we want to learn why. So we think of an interesting question, maybe thinking of maybe their vocal cords aren't as processed as humans or parrots are. So we begin to formulate our hypothesis, which is they don't have developed vocal cords. And then we develop testable predictions. So we'll begin to study and look into why certain animals develop vocal cords or not. We might even, cut up some frozen cats, which some of you are probably doing in your human anatomy and physiology classes. And we look around the throat area and see how different the vocals are from humans and parrots. And then we gather data to test predictions as to okay, if this is the same for this one cat, it should be the same for all cats, and by extent, probably other animals such as dogs or hyenas. And maybe when we get to the parrots, we realize, it doesn't quite work, so we refine, alter, and expand, or maybe even reject it. We basically alter it with every single caveat we can find. And then after all that is said and done, we develop general theories for why this happens or why this doesn't happen. And from there, we publish, we work up the data, we send it to a bunch of nerds for them to look over and see we didn't do any funny numbers, see if they can retest it. And then the whole cycle goes back all over again because we also need to keep thinking, what if we need to redefine this vocal cord theory? What if, other animals are beginning to, not really don't have these speech patterns, but they're almost like they're trying to communicate. So we begin to make even more observations of that and refine our theories about how animals communicate, their language processes, and such and such and so forth. Now, the one person who redefined the scientific method was Antoine Lavoisier, and he developed the law of the conservation of mass, which says that matter is neither created nor destroyed. And he developed this theory while working with his wife, who helped translate some of the articles and papers into French for him. And Antoine Lavoisier, he was studying why certain things, because at the time there was a idea called phylogeny, which basically has this point where mass is lost. It's lost into the air. And Antoine Lavoisier decided to compact together some material to determine whether or not mass is being lost or not. And he discovered that mass isn't being lost, it's just being redistributed. There is nothing being created or destroyed. It's just picturing a solid going to a gas, or a solid going to liquid, like an ice cube. You melt it, it goes into liquid form, and some it goes into gas form, but it's still water. You have 18 grams of water to start with. You melt it. Some of it goes into the air, and some of it becomes melted. Nothing is lost. If you capture it all, it was just the water turned into liquid gas. It's still 18 grams. It's just distributed into different areas. Nothing is being created nor destroyed, and Antoine Lavoisier discovered this along with his wife's help, and that is what became the law of the conservation of mass, and is the reason why that the phylogestine is no longer applicable anymore because, well, it just isn't, because matter is not being created nor destroyed. Matter is being conserved. Matter is staying how it's always been, 18 grams to 18 grams, regardless if it goes to liquid or gas, which is what the phylogestine contra does not say, because it's saying mass is being destroyed, it's disappearing. So anti-Lavoisier disproved that notion. Now, the difference between a law and a theory. The law is a description of a phenomenon, like the law of gravity. Like, again, apple, drop it down from the tallest building in, let's say, New York City, and it falls on someone's head. Well, that's gravity. Gravity is what's pulling it down. It's a description of what's happening. It's saying this will happen if I drop an apple. And there's usually math involved. There's usually a lot of math involved, and it's what generally describes the relationship between the forces pulling down that apple and how much its weight is. Like, if you get a feather, it'll fall really, really slow, even though the force is still pulling it down. Because of its lighter mass, it will fall it'll just fall differently than, let's just say, the apple, or it'll fall differently due to its much heavier mass. Meanwhile, scientific theory, which is something most people do not quite understand because of miscommunication and all that, scientific theory is basically an explanation of why or how or what's causing a certain phenomenon. It's been And both of these are backed up by thousands and thousands of peer review, research, laboratory, data driven evidence. And the thing is that these two can be disproven, they can be rewritten, they can be revised, they can even be expanded upon. And usually many people confuse scientific theory with just, oh, it's just a theory, which is not true, because scientific theory has evidence to back it up with. While a theory is just, I wonder if eating that Taco Bell burrito got me to stay in the toilet for that long. Meanwhile, scientific theory will basically say, well, not that. It will say something else, and it'll be backed up by data and evidence and all that. It's not just something you come up in the blink of a second, something that you have to do in a lab just to see, okay, this worked, this is how it happens, and this is what's going to happen. And one example that's kinetic molecular theory, which we will later visit in a few videos from now. There are a lot of professions about chemistry, or professions that involve chemistry, such as chemistry does education. That chemistry teacher who probably didn't really teach you much about chemistry in high school has a degree in chemistry or another scientific related topic area, and thus chemistry is involved in education. However, there are people out there who are in education who are developing new ways to teach chemistry in college and high school settings to improve and expand upon and try to get students motivated about joining chemistry, since chemistry is a taboo area in science, because not many people like chemistry due to the difficult content involved. But hopefully through these videos I might be able to help convert most of you to chemistry, or at least get you to understand that chemistry can be fun, it is hard, it will make you cry, but it's not impossible to learn and maybe even love. Medicine involves chemistry. I mean, how do you get all those little drugs that make you sleepy, happy, and all other things that may or may not be legal? It involves chemistry, from making those pills to shooting up full of insulin, anesthesia, or some other type of drug. It is everywhere. It determines of how doctors analyze what's going on in your body, what your body chemistry, so to speak. There's also non-chemistry degrees that involve chemistry, such as cooking. Some cooks actually use chemistry to determine what temperature to cook a food or what to add to expand upon that food. And just talking about food is making me thinking I could really go for a burger right now. But yes, chemistry is involved in food. Surprise, surprise, surprise. You just don't think about it. You just do it because it's food. You're hungry. You don't care how you can perfect the perfect meatball. You only care about, I want to get fat and full quickly. And there are other non-chemistry related areas such as engineering, like chemical engineering. Yes, it uses and involves chemistry, but it doesn't utilize it to a big area. It just uses it for engineering aspects, but it still involves chemistry. And there's also, biology and physics. Physics, I know, talks about gases and kinetics and thermodynamics and electricity and what have you not. Like I said, there are many fields that utilize chemistry. I don't know about, um, well, I guess being a history major, you will involve some chemistry if you're doing like the history of chemistry, but I mean, that's a little bit far fetched. And also the legal field. I know that some of you probably have heard or seen Criminal Minds. And yes, there are forensic experts who literally go into a room, take all the evidence, examine it in a lab, and determine, okay, this is what the killer probably had, and probably had or left at the scene of the crime, or this blood belongs to someone else, or someone who decided to dip from the scene of the crime. Those people will go testify in the court of law and tell them, okay, this is what our lab and analysis showed, what it says, and that guy over there is the killer. That type of thing, but hardly ever gets seen in popular TV shows like Criminal Minds. It is usually hinted at or subtly referenced to, but it's usually not deeply involved in the whole chemistry aspects of forensics. Now, as I mentioned before, this introductory chemistry course will involve a lot of stuff, basically. The periodic table and trends, metric conversions, mass conversions, solutions, gas laws, thermal chemistry, chemical equilibrium, balancing chemical equations, which will be fun when we get to redox equations, basic electrochemistry, and nuclear chemistry. We will also include basic organic and biochemistry, acids and bases, inorganic nomenclature, which basically means how we name stuff. Also, we will view YouTube videos that contain lab, typically covered in introductory chemistry courses, with explanations as well as problems that are asked on labs, such as calculations or applying the theoretical aspects, which is basically all the stuff that I will be talking about to a great depth and how we apply that to chemistry. All of that learned in an introductory chemistry course, regardless of where you take it at. And also, I will try my best to make these videos interesting, fun, and using videos of explosions to talk about, chemical reactions such as fireworks, how all those come together to make those pretty little colors you see every New Year's Eve and on the 4th of July. And well, that's all I have for you guys today. The next video will cover the periodic table, periodic trends, elements, atomic number, how the periodic table got discovered, and all sorts of fun stuff that hopefully will make sense to you as you continue on with your chemistry education. Thank you for watching.